Since this is a two process solution, I told you that it works only for two processes. Assume that P0 and P1 are the two processes for which I am going to run this solution. I'll take these two processes and I'll show you what happens if these two try to enter the critical section. Just remember that what happens here is, first thing is there will be entry section. So entry section means this one, this code, right? And then there will be critical section, and then there will be exit section. So every process should go through these three. First they should go through the entry section, and if the entry section let them go through, then they can get into the critical section, and after coming out they should run this. Okay, now assume that we have two processes, P0 and P1, but before that, what are the variables that are global here? So one global variable here is interested and other global variable is turn. So I am just writing the both the variables so that we shall see how they are modified. So one thing is interested here. So interested of 2, which means interested is going to contain two memory locations. One is interested of 0 and other is interested of 1, right? These are the two memory locations, and the other one is turn. So turn is one more memory location, right? Now say P0 has started its execution, and P0 has run the first line, and P0 has run the second line, which means see, when P0 executes the first line, it is nothing but declaring that it is not actually running anything, that is just a declaration. And second line is P0 is computing other. So what is the other for P0? It is P1, right? I mean 1. And then interested, so third line. So whenever P0 executes line number 3, it will set that its interested value is true. See this, which means this one will be true. That is what happens. Initially both will be false, right? Which means this one will be false as of now. Initially we initialize this interested as false, which means both will be false, and now P0 has shown that it is interested is true. And the other one is turn equal to process. So what is meant by turn equal to process is, this value is going to be 0, which means it is saying that I am interested in getting into the critical section, and it is also declaring that it is my turn. That is funny here, right? So it is only declaring that it is my own turn, and then it will go into the fourth line. Now check this. Fourth line is showing while interested of other is true, which means interested of this one, if it is true and turn equal to your process, you are supposed to wait. But since the other process is not interested, you need not wait in the while loop. Therefore, after executing the fifth line, then definitely P0 will come out of this entry section and it will enter the critical section, right? Assume that P0 has entered the critical section by following all these lines. How will it enter it? Because obviously interested of other equal to false, that is how it entered, right? And now it got preempted. Yes, at this point it got preempted. And now assume that P1 has started execution and P1 also want to enter the critical section, therefore it has entered the entry section. Now first line, second line, they are simple. So other is nothing but 0. Now interested of process equal to true, which means P1 is saying that I am interested. And the second one is turn equal to process. It is even saying that it is my turn, which is wrong, but still it is saying that it is my turn, right? And now while interested of other equal to true and turn equal to process, which means interested of other, which means this one. Interested of other means what is the other for P1? This one. If interested of other equal to T, true, and turn equal to process, you are supposed to wait. Okay, let me write. First line is over, second line is over, third line is setting the interested value, and fourth line is setting the turn value, and then fifth line is while loop, right? Now while loop is saying that while interested of other is true, is the other one interested? Yes, 0 is interested. Why? For P1 the other is 0, right? So 0 is interested, and turn equal to process, which means the turn is its own turn, then you are supposed to wait in the loop. Check this, the while loop is just a nothing there, right? So P1 will fall in this infinite loop. Understood this? What has really happened? So here it works this way. Any process who is interested in entering the critical section should check if the other process is also interested. In case if the other process is also interested, then there is a chance that other process might have proceeded further. How can you check that whether the other process has proceeded further? In case if you are the last one to update the turn, which means if you watch it, process number 0 has already updated the turn to be 0, and then process number 1 updated it last. So already the other process which is interested, why you have already checked that it is already interested, and now it has already passed you. That is how you are the last one to test, set it. If you are the last one to set the turn equal to 1, which means the other process might have already passed you. That is one case, right? Or there is also one more case I'll show you. So then you are supposed to wait there, right? How long? How long should you wait? Until the other process comes out of the critical section. Now assume that P0 is done with its critical section and it has entered the exit section, line number 6. Now if P0 executes line number 6, then what happens? It is showing that interested of process equal to false, which means here it is showing to be false. Fine. Now P0 is saying that I am not interested anymore. Fine. And it gets preempted. Then if P1 gets into execution, again it is still in line number 5. Let's see what happens in line number 5 now. Interested of other equal to true. Now is the interested of 0 true? No, it is false. Therefore it is going to break. Therefore only if the other process shows that it is not interested, then you can enter into the critical section, right? So at this point you can enter the critical section because P0 has come out. So one thing you should understand here is, as long as other process is not interested, you can always enter the critical section. Therefore progress is guaranteed, isn't it? As long as other interested is not true, which means interested of other equal to false. If no other one is not interested, you can directly break this loop and get into this critical section. Therefore a process which is not interested in entering the critical section will never block a process which wants to get into the critical section. So one thing is, progress is guaranteed, isn't it? And now if you look at these sequences, only one process is able to enter the critical section and the other process is able to is blocked. Therefore mutual exclusion is also guaranteed. It is a strong statement and I need to prove it. I'll prove it with more examples, but still just remember that mutual exclusion is also guaranteed, right? And what about bounded waiting? We shall see that. How long is a process going to wait? We shall see that with examples. And anyway it is architectural neutral, which means we are not taking any help from the operating systems, right? Now we shall see one more execution sequence using which I'll show you what happens when these two processes execute in any order, random order. Okay. Now in the earlier example I have shown you that when two processes they try to enter one after the other, there is no problem. But what if the two processes try to enter simultaneously, which means if they are in this entry section simultaneously. In the earlier example what I have shown you is one process has completely entered this, completely passed through this entry section and entered the critical section, and during that time the interested of other process is completely false. Or what I wanted to exactly know is, let us say there are two processes and two processes have entered the entry section simultaneously and they are getting preempted one instruction after the other instruction. Now which one will enter the critical section first? That is what I wanted to know. What I mean to say is, let us say one process has executed this line number 3. 1, 2, 3, 4, 5, 6. Assume that one process has executed line number 3, right? And then the other process has entered after this, and then it has entered line number 4, executed line number 4. So what I wanted to know is, which one will enter the critical section? Whether the one which has entered the line number 3 first, or whether the one which has entered the line number 4 first, right? So in fact what I wanted to know is, P0 has executed say first line, second line, third line and got preempted, and then P1 has executed first line, second line, third line, fourth line and fifth line, right? And I want to know what happens now, which means one process has executed line number 3 first and other process has executed line number 4 first. Out of these two processes, which one will really win the race and which one will enter the which one will take over this critical section first? I just wanted to know that. So for that, let me analyze it. So initially interested of 0 and interested of 1, and then there is turn variable. Okay. Now P0 is executing 1, 2 and 3. So 1, 2 and 3, initially these two will be false and false, isn't it? Interested will be false and interested will be false. That is initial state. Now P0 has executed 1, 2 and 3. So what is third line? It will say that it is interested, which means P0 has said that it is interested. Interested equal to true. And what about P1? It didn't enter it. And now at this point P0 got preempted, and then P1 came for execution, right? And now P1 has executed 1, 2, 3 and 4 and 5 also. So at the third line for P1 is interested of process equal to 2, true, which means P1 is saying that it is interested. And the next line is, it will even set that it is its own turn, which means turn is going to be set to, here turn variable will be set to 1, which means P1 is true. Then what happens to this? While interested of other equal to true, is the interested of other true? What is the other for 0, 1, 0, right? Yes, interested of other equal to true, and turn equal to process, yes, which means turn equal to this one, process 5, right? Turn equal to process 1. Therefore these two conditions are true, and so the process P1 will get struck in the while loop. So what happens to this P1? It will get stuck in the while loop at 5. How much ever time you let P1 to run, it is going to be at line number 5 without leaving the entry section, which means entry section is blocking process P1. So it looks as if the process which has set interested value first, which means the process which reached the line number 3 might enter the critical section, isn't it? Why? The process which has entered line number 3 late, he has now got stuck here, isn't it? Is not going into the critical section. Any number of time, how much ever time you allow it to run, it is never going to get into critical section. That is what happened here, isn't it? But now let's see what happens if I now let P0 to run. Now P0, if I let P0 to run, what is next instruction that P0 will go for? After 1, 2, 3 it will go for 4. So what is fourth instruction? Turn equal to process. So what is turn here? Turn equal to process means it equal to 0. So now turn equal to 0, and now it will enter the fifth line. While interested of other equal to true, which means what is other for P0? 1. Yes, interested of 1 equal to true, and turn equal to process. Yes, turn is equal to process. What is the turn now? 5. So even for P0 these conditions are same. So P0 also got struck there. Check it out, isn't it? Now P1 got struck at line number 5 and it was not able to get into critical section, therefore it got struck. And again P0 also at line number 5 it got struck. So is it a deadlock? And then who is going to get into the critical section? Now any amount of time you let P0 to run, it is going to stay there, right? Then what happens now? Think about it. Now let us say after some time P0 got preempted, and now P1 is running again. So at this point P0 got preempted, and again I scheduled P1. So what is the line at which P1 got struck? 5. Therefore again it will execute the line number 5. Now let's see what happens. Now interested of other equal to true. Yes. Why? The P0 is interested, and turn equal to process, that will become false now. The reason is, now turn equal to 0, turn is not equal to 1. What is turn equal to process for P1? Turn equal to 1, but then turn is equal to 0 there. Therefore this second condition failed, so this loop will break, and so this PS will come out and get into the critical section, right? So even though it looks as if they are stuck in deadlock, if you allow it to run for next time, it will definitely end. So now you should understand one thing. The process who has set line number 3 first is not the first one to enter. The process which has set turn equal to process, this line number 4, any process which executes this line first is actually entering into the critical section. Check it. Which entered, P1 is the first one to enter line number 4, and therefore P1 is the first one to enter critical section. How did this happen? Simple. See this. Now the while loop will break only in two conditions. One condition is if the other one is not at all interested. If the other one is not interested, then any process can get into it. Or if the other one is interested, and turn equal to process means if other one is interested and you are the last one to set it, you have to wait, because earlier before you someone might have set the turn. It is somewhat difficult to understand. Maybe I'll take one more example and again I'll trace it out. Try to follow this. See, a process, if other process is not interested, then it is going to break and definitely can enter the critical section. Fine. If other process is also interested, then how can they enter the critical section is if you are not the last one who has set the process, which means if you are the first one who has set it, then you can enter it. That is how the code is working. Are you understanding this? So whoever sets it last, they'll always see that turn equal to process and other one is interested, therefore they get blocked there, right? And whoever sets it last means someone, I mean first, whoever has set it first, which means someone has already set the value of turn, right? I mean you have set the value of turn and after you someone has entered, which means you are the first one who has set the value of turn, then you can enter, right? So simply put, it is like this: if only one process is interested, that can always enter it because of this interested of other equal to true. And second one is, anyone who has set this turn equal to process first, they will enter the critical section first. If you are the second one to set turn equal to process, then you have to wait. Why? Because turn is always going to be your process number, isn't it? Okay, if you didn't understand it, let me trace one more example here. See this? If you still didn't understand it, let's see this. Assume that I have interested of one is 0 and other is 1 and the other one is turn. These are the two variables I have. Now what is that I am going to do is P0 is going to execute 1, 2 and 3 lines. So what happens, P0 has executed third line, means it is showing that it is interested, true. And again P1 has executed, let us say 1, 2 and 3 lines, which means P1 is also showing that it is also interested. And now P0 now got scheduled and it has executed fourth line first, which means it is saying that it is its turn. So therefore turn equal to 0, that is what it set. And now it has gone into 5. Now what happens? See, while other is interested, yes, other is interested and turn equal to process, which means it is the last one to set the turn value, it is supposed to wait. Therefore P0 is going to wait, right? How long? Okay, let's see that. And next one is, after this P1 got scheduled and P1 got executed fourth line. What does it mean? Fourth line means P1 is saying that now it is my turn, right? Therefore who is the first one to set this turn value? 0, I mean P0, and who is the last one to set it? P1. Therefore who should enter the critical section? P0, right? Therefore P1 should get blocked. Let's see this. Now what happens here is, while interested of other equal to true, what is the other for P1? 0. Yes, interested of other equal to true and turn equal to process. So what is turn equal to process? Is it turn equal to process? Yes, turn is equal to 1. So it is going to block there, get blocked there. Therefore, since it is the last one who has modified turn, turn will reflect its process ID, right? Therefore it is supposed to wait there, right? And now what about the other one? Now watch it. When the other one gets scheduled, P0, it will again run the line number 5. Now when it runs the line number 5, it finds out that other one is interested, but other one is the last one to set the process ID, which means, I mean turn, which means turn is not now 0, turn is 1. Therefore this while loop will break and P0 will enter the critical section. Are you understanding this? So whichever process has entered the line number 4 first will enter the critical section first. You should remember that. In this case, P0 has entered the line number 4 first, therefore P0 is entering the critical section first, right? And P1 is the one which has entered the this one last, therefore it is supposed to enter the critical section last. Then what happens? Assume that P0 is in the critical section and then it came out and it entered the exit section 6, which means it is showing that its interest is false. So once it makes its interest as false, right, definitely other one will get the chance, right? So now what happens? Check it. It has made the 6, and now other one P1, when it gets scheduled, it will again run line number 5 and there it will check that interested of other equal to false, which means other is not interested, therefore the while loop will break and it will enter the critical section. Got it? Therefore once P1 has got P1 where is it? Yes, once P0 has entered the critical section and once it comes out, P1 can obviously go into the critical section. Therefore here there is mutual exclusion, because out of all sequences we have seen, every sequence is leading only one process. So therefore there is a mutual exclusion, one thing, and second thing is progress is definitely guaranteed. Oh, okay. So how is progress guaranteed? If a process is not interested in getting into the critical section, then it can never stop the other one. How? Because of the interested, right? If it is not interested, it cannot block the other one because of this line. If interested of other equal to false, then you can obviously come out of the while loop. Therefore, a process which is not interested can never stop a process which is interested. So second condition is progress is guaranteed. Fine, two conditions are satisfied. And what about the third one? The third condition is bounded waiting should be there. Bounded waiting means there should be a kind of alteration. So if P1 wants to enter it and P2 also wants to enter it, let's say allow P1 for some time, one time, and then after let us say, I'll just show you with this example. Okay, here let's say this. P0 and P1 both are interested in getting into the critical section, right? And now P0 entered the critical section first, right? And then P1 should be the next one to enter the critical section. How? Let's see this. I think you followed till here. See, if you didn't follow it, please rewind the video and watch it. What I'm trying to say is P0 has entered the critical section first and it came out, and P1 wanted to enter the critical section and it's still waiting. And assume that P0 again is interested in getting the critical section. Let's see what happens now. Now P0 will again execute line number 1, line number 2, line number 3, and say line number 4 again, right? Then what happens? See this, line number 1, 2, 3 says that P0 is interested, which means interested of 0 is true. Fine. And then line number 3 and 4 says that turn is P0, which means it wants to get into the critical section, right? And now what happens at line number 5? At line number 5, it will see that interested of other equal to true, which means P1 is interested, and turn equal to process, turn equal to its own thing, right? Its own number. Therefore, it is nothing but you are the last one to have set the turn value, which means before you someone is already interested and someone has already set it and you came last, therefore you are supposed to wait. So P0 is going to wait here forever until P1 gets into the critical section, which means if P1 and P0 both are interested in getting into the critical section, then P0 can enter only one time and then P1 has to enter it. So see this, now P1 can get into it, right? So now P1, when it executes line number 5, obviously P1 got stuck at line number 5. When it executes line number 5, it will see that turn value has changed and turn value is no longer its own process value. Therefore, it will break and enter into the critical section, right? In case if P1 has not reached the turn value, right, then what happens? Then again P0 can enter. But once a process has reached the turn value, obviously it will reach it, right? So what I mean to say is, once a process has shown its interest and it has set the turn value, it will not wait indefinitely. It will definitely wait for only one time for the other one to enter. Or here there is strict alteration. Strict alteration is definitely followed. As long as both the processes have been waiting in the while loop, a process will never wait in the while loop forever. Once the other process has come out of the critical section, definitely it should give the chance to the other one. It cannot enter the, see, I am saying that if two processes are stuck at while loop, one process will enter into the critical section, and once it comes out, it cannot enter the critical section again. It should let the other one enter it. Therefore, definitely bounded waiting is there. What is bounded waiting? A process need not wait forever in order to get into the critical section. Therefore, here process is not waiting forever. If you observe it, process is waiting only for other process to get into it and then come out of it. So definitely bounded waiting is also guaranteed. We are not going to wait forever. And what about the platform neutrality? Platform independence or architecture neutrality is your solution should not depend, or it should not say that I can only work in one operating system and I cannot work in other operating system, or it cannot say that I can work only if the hardware is having these instructions. Obviously it is not saying so, isn't it? This is a generic solution which can be implemented at the user mode, so no support is required from the operating system, isn't it? So this is even platform independent, right? Only disadvantage of this method is it is applicable only for 2 processes. Other than this, this is the best known method which is used at the user mode. As there are other methods which are better than this, but then they all require the support from the operating system or the hardware or the instructions. Without making any assumptions about the operating system, if you want any solution at user level for 2 processes, this is the best one, right? Understood this? Fine.